Okay, another concept is that not every group of three segments can be used to form a triangle. The lengths of the segments must fit into a certain relationship. Okay, so let me try this. So if you have like this triangle, for example, or I'm trying to make a triangle, see these legs, there's no way that these could form a triangle, right? There's nothing I can do with this leg or, hold on, let me try this. Didn't mean to do that. But anyway, there's nothing I can do to make this form a triangle, right? It just couldn't happen, right? Okay. Or this, for example. This, like, say if this was 5. Oops. Say if this was a length of 5, and that's a length of 3, and that's a length of 2. It still wouldn't make it, right? You couldn't form a triangle. So that brings to mind here that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So that's the triangle inequality theorem. Okay, you can write that down and get caught up. So in this triangle, for example, you would have AB plus BC must be greater than AC, and AC plus BC must be greater than AB, and AB plus AC must be greater than BC. In other words, for every pair of two sides, they must be greater when added together than the third side. Okay? So you can kind of think of it this way if you'd like, that you have, say, this third side is the schoolyard bully, and he's going to take your lunch money, okay? And these two guys have to get together to prevent that from happening. If these two guys combined are greater than these two, they get to keep their lunch money. They get to form a triangle. But if they're not greater than the third side, then they have to go home. They didn't make it, and they can't form a triangle. Okay? So the operative word here is and, okay? All of these things have to be, in effect, all of these statements have to be true in order for the legs to make a triangle. So it has to be this, and this, and this. All three have to be greater. All three of those statements have to be true. If any one of these is not true, for example, like that one, then the legs will not be in the right relationship to form a triangle. Okay, so again, the operative word here is and. So let's look at a typical problem that you would get. A triangle has one side of 11 inches and another of 15 inches. What is the range of possible lengths of the third side? And I would like you to answer in this fashion using an inequality or a range of answers. That's not the correct answer, of course. That's just a little example. So I want you to say something like 3 is less than x is less than 45. So let's shoot for the smallest values of x. Okay, let's try to calculate the smallest range of values of x. And in order to do that, we're going to assume that x is the shortest side. So if x is the shortest side, it has to combine with his buddy 11 because 15 in this case is the schoolyard bully about to take x's lunch money. So he has to combine with the 11, and that has to be greater than 15. So to solve for that, you subtract 11 from both sides and you get x is greater than 4, which also you can have, right, or 4 is less than x, right? Just reversing the order of that statement. So just to kind of explain what's going on, right, I just thought of this. I can do, just to kind of give you a little explanation here, you can have that, and then let's say that, and then let's say this. Okay? This would be your x value, and this would be 15, and this would be 11. So again, you have to combine with your partner 11 to prevent the schoolyard bully from taking your lunch money. And that gives you the statement 4 is less than x. Okay? Alright, and then moving right along, to calculate the large values of x, we're going to assume that x is the longest side of the triangle. In that case, x is the schoolyard bully, and the 11 and 15 have to join forces and prevent their lunch money from being taken by the schoolyard bully. So if you solve for that, you get 26 is greater than x, or x is less than 26. And a picture of that would be something like this. Okay, or hold on, something like this. Oops. Why is it doing that? Okay, and then this would be, oh, I can't quite get it right. Let me try that again. Sorry about that. Maybe this is a little bit better. Okay, this would be your 11, this would be your 15, and this would be your x. So in this case, again, the 15 and the 11 have to join forces because in this case, x is the greatest value, or x is the schoolyard bully. So 11 plus 5 has to be greater than 11 plus 15, has to be greater than x. So that turns into x is less than 26, and it has to be greater than 4. So the way you can combine those two concepts at the same time is like that. Therefore, 4 is less than x is less than 26. In other words, in order for you to make a triangle that has one side of 11 inches and the other side of 15 inches, the third side has to be greater than 4 but less than 26. It can't equal 4 and it can't equal 26. Okay, if it was able to do that, it would be less than or equal to, right? Or greater than or equal to. But this is saying that it's greater than or less than, no equal to. So the range of values is anywhere in between 4 and 26 exclusively. In other words, between 4 and 26 and not counting 4 and 26. So here's a low down, quick and dirty way of figuring this out. Maybe you've noticed. What you could do to find the small range, the small number, is to go 15 minus 11. 15 minus 11, you might have noticed, is 4. And then you go 15 plus 11 to give you this value, 26. So you just basically take the two values and subtract them to get this value and add them to get that value, and x has to be somewhere in the middle of that. So I hope you understood that explanation. If not, please feel free to contact me at your convenience, and we'll set up a time to meet, and I would love to help you out. It would be my pleasure to help you and answer your questions. Okay? Well, that was the end of the lecture, and I hope you understood it. All right, thank you. Bye-bye.